Hello everybody, welcome to another stream. Excuse my hair, it's a bit of a mess, the ceiling fan's on, it blows it everywhere. What are you going to do, Right, so yeah, yesterday we realised that there was a bit of an issue with how we'd currently implemented some of the workflow. It turned out that we'd missed one important thing, and also that there was a typo on the diagram that I was working from, and it had a singular and not a plural. Right, let's show you the diagram. Here we go. Right, let me just pull this across a little bit. There we go, like so, I suppose. So yeah, assign placements to phase is what we basically started working on yesterday. After yesterday's stream, I did a whole bunch of extra work. Must have finished around midnight or something like that. It was there was quite a lot, and I've got it into a particular, there's a nice state which we can continue from today. So let's have a look at what is there now and what we need. So we've got a failing test, happy days, and what we've said is that we want to assign some placements to a phase using some form of sort of like criteria-y arguments, right? Yeah, so that we wrote this down yesterday and it was all good. But in order to do that, there's a whole bunch of sort of groundwork that needs to be laid first, because we didn't have any notion of any placements within the project. So one of the first steps that we do is create a job. The next step that we do is assign a variant to a unit. So that's where you say this design's variant is this PCB that we want to place, right? And we want like 6 of them in a panel, right? So each of these has like a unit number. And at the end of that, we have this sort of unit assignments, right? But we don't have anything, and we don't know anything about the placements at all within the project. There's nothing. But now, we do. So this test says when you assign a unit to a project, a design variant, right? It's got a path, and I poked the path around just so that it's easier to do the implementation of it. So path chunks are separated by double colon. It's Rust, isn't it? Double colon for everything. And then it's basically like a key value separated by an equals, right? And this is called a unit path. But we're going to use the same thing for the refdes paths as well a bit later. So anyway, we've got this unit path, and what we now say is that there should be some placements that are made, and this is getting quite large. This test file is, but anyway, it tells us what we need to do. So once you do that, the project file needs to have a list of placements. It needs to have an object path to the placement. So panel 1, unit 1, refdes J1 is this, right? It's got a unit path for the unit itself, and yes, you can get that from here, and maybe we don't need this here. Yeah, I'm still working out the details. Maybe there's some overlap. So basically, when you combine the unit path and the refdes from the placement, you end up with this, and this is the key to access one of these placements. So later, when we come to actually place the placements, we'll say this one was placed, this one was placed, this one was placed, and we're going to be recording that in this state here, right? And we've now got the concept of a placement within the project, which is good. And we've also got this status thing. This is a bit funky, this is. So when you first assign a unit to a variant, it has a given list of placements, right? But if you then refresh the project from the variant builders artifacts, so for instance, you decided that this variant should have another component on there as well, and you recreated the list of placements, you then need to refresh the project. And what can happen is that you can either change the details of placement, you can add a new placement, or you can remove a placement. So if it was there previously and you've refreshed the project, then the status will be known. But if you've removed it, this needs to go to unknown, so that you can then present the user with a list of things that shouldn't be in the project anymore, and they can decide, oh, well, that's an error, or yes, I'll delete it, or give them like a little report, like a refresh report or something like this. So we've got this. Right, we're all good. And then we just, continue with this list of placements. So we've got J1, we've got the R1, and we've got the R2, which is great. And those come from the design variant placements list, right? Which is the CSV file that the other tool spits out. So this is all good. It was quite a bit of work to get it to there. I did a work in progress commit, which we can have a quick look at. Yeah. So in order to get to this point, we basically had to do quite a lot of stuff. We've updated these part states. There's not really much in part states anymore. That all got updated. We changed the path for these unit paths to use colons, and all of the tests have basically got the list of placements in it. And the new test that we've got, when we want to assign something to it, it's supposed to have a phase there now. See, phase, and this one doesn't have a phase. So that's what we've got to do in a bit. Yeah, and then more poking around of some of the tests, and then the production code had quite a lot of changes to it. Yeah, so we've got our new command, which we had yesterday, and there was a bit of duplicated code at each of the commands. They basically sort of refreshed the project, I noticed, so I refactored that out. So now we've basically, instead of repeating this all the time, we refresh the project from design variant. Great. And that will refresh the list of parts and also now the list of placements. Yeah, and then we use that on our new command as well, which is good. Yeah, and then we've got the project refresh, which now has a refresh parts and also a refresh placements now. And the refresh placements was fun. Let's have a quick look at the project to see what it now contains. So this is the new bit that I added yesterday, which is a B-tree map of object path to placement state. Right, now there was quite a lot of fapping about with this, because this object path is actually implemented as a vector of tuples of string and string, as in the key and the value, right? And it has a display where things are joined, and then we've got this from stir, which basically goes the other way around, which takes it from a string and then gives you an object path. And then the idea is that you would be able to do other things with the object path, such as like match on things and just look at the individual components of it and so on. But if you use that as a key and then try to serialize it in the placements, you would basically like be serializing all of the elements in this giant JSON block, which is just nightmarishly verbose. So we want to serialize it in the nice string format. which meant quite a bit of fapping about trying to work out how to do that. And it turns out you can use display from stir from serde as to do it. Yeah, object path. There was quite a bit of to and fro in trying to get some other things to work, which we can now delete. Happy days. There's a clippy warning about using trifold instead of fold here. I'll fix that at some point. Yeah. Why do we have this deserializer? And I think there might be some warnings to clear up as well. So we can just quickly do this. Let's also quickly run the tests on the command line. There we go. Hopefully they all pass. Yeah, we've got some warnings to clear up. They all pass apart from the one that we haven't finished yet, right? Which is good. Right, let's deal with these. Let's deal with these warnings. Let's see what we get. Right, those ones were all okay. So I think it's just this one. Yeah, there they are. Oops. Guess we don't need that. Oh, that's interesting. Maybe we don't need this part state anymore. This is what we're going to have to do soon, so we need to leave this here. Yeah, okay, we're good. Right, let's just update that work in progress commit with those changes. Yes. Okay. Yeah. So that's sort of where we're at the moment, anyway. So the next thing to do is to try and use these, use these arguments that we defined yesterday. Where's my test? This one. So the next thing to do is to try and make this work, and then add the phase, and we'll see how we get with that. So yeah, it should be fairly easy, I think. I think most of the work was getting the placements there. All right, well, let's see what happens. Let's write it here and then extract it to a method in a bit. So I guess, well, we've got this project and it's got a bunch of, it's got a map, and we need to get all the keys and see if any of them match the thing, I suppose. So I suppose we can go yeah, for entry in project placements, and then I suppose we'll filter this. Should we filter it here and then we just work on the ones that it found that matched? Yeah, that seems about right. How do we do it? Iter dot filter, yeah. Foo, what do we get here? We get the object path and the placement state. Yeah. So let's go path and then state. To do the filtering, we're not going to need the state. Oh, that's not supposed to be one of those, is it? And if we just say true there, what happens? Oh. We're missing a bracket. There we go. That's better. There we go. Does this compile? It does. That's good. Right. So now we can look at the path and see if it matches, which should just be should be something like placements pattern dot is match for the path dot to string. Oh no, dot as display. Perhaps. Let's have a look at object path. So object path implements display, and we want to use this thing from it. I've never used this as display thing before. And then what does this give us? This gives us a string. But what does as display do? Oh. How does the display trait work again? Let's have a look. Okay. I'm not entirely sure. Let's say let path stir, and then let's just say format it, I suppose. There's probably a better way of doing this. So we get a string, and here it wants a string, and it's just that, right? Yeah, yeah. Why not? And then if it does match, then we I think what we can do here is go dot values. I'm not sure. Let's forget that. So now we can update the state. So we can go state dot, and then we need to poke the phase. But we don't have a phase in here yet, so I suppose we need to add one. And then phase, right? So this is going to be an optional phase name. Yeah, why not? But it doesn't like that. Why doesn't it like this? Because this probably needs to be it's a mut here. So we get a mutable state. And the phase is moved, so we need to clone it. Sure. Missing field phase. Everything's fine. Yeah. Yeah. Okay. Right. So now we've broken all the other tests because phase is now going to appear there, but we don't want it to appear there unless there is a phase. So let's poke that. So when we serialize stuff, right, we can say skip serializing if whatever. So we can do this thing here. And then if it's none, you use the default. So that should fix the other tests. Hey! Right, but now what's the problem? Let us see. Okay. Well, that didn't work, did it? Is our pattern wrong? Did the match fail? What happened? What happened? I don't know, I thought that might work. Like, it seems like it could have worked. So we iterate over all the placements and we find an object path and then we say, is it a match? Let's have a look at our test setup just to make sure that our arguments are right. So okay, let's do a quick let's use the amazing website, which is regex 101. If people don't know about this, they should do. This is one of the best sites I found, online sites for fiddling around with the regular expressions. So we're using Rust regular expressions, and the regular expression that we said we want to use was this. Okay, and the string that we're going to use is going to be, well, there's a couple of them. This one, no match. Do we need it to do this? No. What have we done? Oh, because I haven't updated it to include the ref des. Everything's fine. Yeah, okay, fine. Now it matches. There you go. I added this bit yesterday. Fine. So our test was wrong. There we go. Okay. How about now? Fail. Oh, but you know, it worked, but it's just in the wrong order. Everything's fine. Okay, so phase is last. Okay, I can work with that. Right, and then we've got to fiddle about with commas. Ugh. I really wish that the JSON thing just, you know, supported trailing commas. Ugh. Hey, it works. We've assigned a placement to a phase. Right, that's it. Finish the stream, we're done. No. What's next? There's always something to do. Hi Darkman, how's it going? But I'm right. So yeah, you know, it works, doesn't it? It works. Like, shit. Let's do a work in progress commit to draw a line in the sand, as it were. Amend that commit, right? And then let's just have a fiddle with some of these other regular expressions that we typed in yesterday, just to see what happens, right? So we said we want all the placements to be in this phase. Let's go. Let's see what happens. Right. And they should all have the phase on it, right? So this one's got it, this one's got it, and this one's got it. So yeah, that works. Pretty good. Pretty good. Happy there? What about, let's do a more complicated one. Let's say, oh yeah, we need to update these with double colons everywhere. panel equals, yeah, hold on a second, let me yeah, so now let's do a ref. Let's say for any unit on any panel, R1 goes in this phase. Who thinks it's going to work? I think it's going to work. Right, so there's no phase on R2, which is good. R1 has got a phase on it, and J1 does not. That works. I'm fairly happy with that. That looks pretty good. And let's do an exact match as well, because we haven't tested that. It should work. Because it's only string matching, right? So let's just say panel 1, unit 1, ref des R1. And let's fix up this other example here. I suppose you could do that. Yeah. So R1 should have a phase. Much scrolling. So R2 does not have a phase, R1 does have a phase, and J1 does not have a phase. Yes, that works perfectly as well. This is great. Right, but that's what we said we wanted in our test, and we've updated this. It's fine. Right. There should probably be a unit test for some of this sort of matching behavior, which basically just makes sure that all of these works for the given examples. Yeah. But let's amend this commit once again. Right, we don't do this yet. We don't support this yet. Right, so let's mark that as a future thing that we want to do and amend it once again. Right, so it works. So red-green refactor. Let's have a look at the production code. So this is what we did. Right, but we haven't done this to do. And we need to do that. This is very important. Now, let's have a look at the test, because the test what did we say? Matches the phases PCB unit size. So the phase has got a top, right? And the placements has got no side in here yet. So let's fix that. Right. In order to fix that, we're going to have to go back to the CSV. Oh my god. Here it is. And we're going to need to add side into here. So let's do that. Let's say top. Seems reasonable. Okay. I'm not really sure whether top should have like a capital T on it or I don't know. Since like everything else is capitalized and done in this sort of Pascal case way, I'm just going to say it's going to have a capital T in there for now. Right, so that means that we need to have a PCB side, because it's called PCB side everywhere. Maybe should this be PCB side? Let's be consistent. Where's my PCB side gone? Right, PCB side, and here it's going to be, well, top, I guess. Sure. Lowercase, uppercase. In this project file, we're using sort of lowercase for a lot of things. Well, these are just names actually, so they're not really. We've got lowercase here, we've got lowercase here, lowercase, and yeah. So I think we should use lowercase here. Right, so when we import these, oh, the bloody commas. We're going to say that we want a PCB side. And it also means that all these other ones down here are also going to need that. Which is a bit of a faff. Here. Right, great. So now we can go back into the project and look for the placement state, which has a placement, which now needs to have a PCB side of PCB side. Here's one I made earlier. And look, we've got lowercase on there. So everything's fine. Right, but the problem is, that's going to break some stuff by adding that in there. Like so. So the placement record, which is the CSV file thing.
Version by Weezer from Spotify.
I don't know what's going on there. Alexa, stop. I don't know why it just started playing music. That was pretty random. Right, PCB side, which is going to be a string. I mean, we assume it's going to be a string. Maybe it's not going to be a string. Maybe we should actually... yeah, I say PCB. See, it could fail if we do this. You see, you don't really want it to fail, do you? Well, what are we going to do? Because we can't do this. So do we have an enum called placement record PCB side, which has got a top and a bottom, which can be serialized. Oh yeah, and there was a enum, and then we've got there's a thing. Oh, I've got to try and find where we do this rename on the other enum. That's what we need. That's what we need. We need this stuff. I don't think we need this. And then we can go impl from placement record PCB side for PCB side, right? Match value. And then it's going to be placement record PCB side top goes to PCB side top. Yes, I know this seems quite mad, doesn't it? But the CSV stuff and the project stuff have different implementations and so on. You don't want to combine the two implementations. You need to just convert from one to the other. Right, and now it can't fail. Great. So we can go into here now, I think. Is that right? Can we do this? Can we do that? Or do we go PCB side from this? Do we want a reference here so that we can do this? Oh, it's not. Oh, I've got to change this to be placement record PCB side. Right. Let's just see if we can do what I wanted to do before, which was self, not PCB, into. Right, but we can't. Yeah, okay, well, I think we were into. Wait a second. Let me just take the reference off how I had it before. Yeah, you can't move it. I mean, you could clone it and then do it, but I think probably implement it for the reference makes more sense, and then doing that, because we don't need to clone it to do it. Right, but this needs to have debug on it. One moment. Right, let's try that again. So serialize isn't done on this. I'm a little bit surprised by this because I didn't think you needed to. Okay. I thought just using value num would be sufficient. Okay, so when we're writing the output CSV, we are not writing the thing, and this is in the variant builder now. So we've got to poke the other tool. Oh, look at this! Just spirals out of. Oh dear. Okay, so PCB side. So we need to give it a PCB side. But our EDA placement is one of these. And it doesn't have a side. Oh no. Kind of needs a side. But should it be a field or should it not be? So way back when we were doing all the KiCad dip trace stuff, right? We had our more specialized EDA placements, and we had details instead of fields. But that got refactored, so it's just got fields. And the idea behind the fields is that there are certain things which are specific to the EDA tool that you're using, and you want to keep that information around for a while you're processing all this stuff, so that you can match on things properly using the right matches and all this kind of stuff. However, things like X, Y, side, and place are common to all of the EDA tools. Let's refresh our memory as to what a dip trace one looks like. Here's the dip trace one. It's got side. Let's have a look at the KiCad one. Here's one, look, it's got side as well. Right, so they all have side, basically. So we're good. So we can add side as an actual thing here. Side. Right. And this PCB side thing, where does this live? This lives in planning. However, I don't think it should live there. Because this is sort of something, well, or maybe it does live there really. Because when you're actually putting something on a pick and place machine, you don't need a side. It's always the top, right? I'm leaving it in planning for now. Maybe we'll come back to it and move it later. Yeah, suppose so. Okay, fine. So we've got this PCB side now. Now what happens? Missing field. Build EDA placement from a dip trace. From a dip trace placement record. A dip trace placement record probably doesn't have side on it either. No, it does not. So we're going to need another enum to handle this. Oh, it's just enums everywhere. Right. So where were we a moment ago? So we had these. Right, so we've got placement record PCB side, which is what we use when we're writing the CSV file. But the dip trace one is going to need a side, which is not going to be a string, it's going to be a dip trace placement, dip trace PCB side, right? And maybe it's got some specialist formatting which is different from KiCad, and we want to keep the implementation separate. So, you know, we'll slap this in. We're going to say Pascal case when we're deserializing. Yeah, seems reasonable. And then we need to rename it to this. Okay, good. Right, so that means we can go PCB side self.side, and then I suppose PCB side from this. Right, but we haven't got the implementation for that yet, so we need to do another one of these stupidly trivial match things. But we don't have this yet. And it probably created the wrong thing. Oh no, we're good. Oh, wait a second. We already had that. Should we be consistent in our naming and call it PCB side? Yes. Okay, that probably broke some things. That's supposed to be a comma. Right. We've got the same thing in the KiCad stuff. Which means we need to copy some of this. But it's called side in the CSV file, so we need to keep that as it is. And the same goes for the KiCad thing. So we're going to delete this, paste this, KiCad PCB side. And these are all going to be... Let's have a look at the KiCad one. This is lowercase. Is it spelled like that? And this needs to be KiCad. Right, and this is great. Now we're going to have two missing implementations and a missing import. Right, we've got the two missing implementations. We haven't got this. Right, so let's deal with the KiCad one since we're looking at this file. Impl for wait, what? No. Wait a second. Let me just delete this a second. I'm getting confused myself now. This PCB side is that one. And we're trying to build an EDA placement. And an EDA placement has a PCB side, which is the planning one. Dear me. Oh, I copied the wrong one. Okay. Why didn't anybody tell me? For PCB side, like it says. There we go. Right. But there's supposed to be a reference here. And then we're going to need the same thing for the dip trace one. Oh. And you know, loads of this is just going to get completely optimized out. So, and this is supposed to be a capital T. It doesn't live there though, does it? Right. Well, that's better. Well, now what happens? Oh. Really? Oh, this is supposed to be like this, and this is supposed to be like this, and that's why the error message was wrong. Okay, PCB. This needs to be public. And then we've got, oh yeah, we've got to finish this bit. So now we can create a placement record from the EDA placements.bcb side, I suppose. But this placement record needs to be one of these type. And if you've got from, it means you could do the other way around as well. So I guess you go. Can we just go dot into here? No. What about? Yeah. Okay, so if we go placement record piece from a reference to the EDA placements thingy, perhaps? Expected. Oh, right. Wait, what? Where? Oh, get rid of that. Yeah, hold on. PCB side is a PCB side, and we want to create one of these from one of these. No, Muppet. Wait, am I being a Muppet? Yes, we don't want to move it. No. Am I doing this right? I don't think I am. Let's see what we get if we do this. I get confused with this from and into stuff. Apparently when you implement from, you're supposed to implement from instead of into, right? But when you implement from, you get an implementation of into. So but I'm confused by the error message. It says expected placement record PCB side, but it found. Why would into want one of itself? Right? Like if you do this, what happens? What does it say? The trait from PCB side is not in right. Yes. So if we take a reference and do this, is that what we need to do? The trait from PCB side is not implemented for so we get a reference to a PCB side. Yeah, I don't think we implemented that one. If we go back to where we were a moment ago, which is this PCB side thing, no, the placement record thing, we implemented, what did we do? It says from, okay, let's just implement it. Sure, you know. I didn't think I had to do this, but apparently I do. Okay, fine. Right. What about the variant builder? Did we break the variant builder? Does it even compile? Yeah, you see, we broke it. We probably broke it because the testers probably got some expectations for this PCB side stuff now, or we didn't put it in the file. So we need to look at this and see what's going on. It says CSV deserializer missing field side. This is good. So we're not writing these things yet. So we need to go side, and then dip trace uses capital T. Why? Okay, yeah. Side, and this one's going to be a string for now. And then we've got the KiCad one as well, which we need to deal with. Okay, good. So we're going to need to add this into all of these, which is going to be annoying. Fine. And all the other ones. Okay. And now it says, well, it's probably when it's printing it out now. Yeah. So when we print it out, we're supposed to be expecting some more things now. Expected CSV content. Yeah, here we go, look. So we need to specify PCB side or whatever. And then this is going to be top, like this. Okay, no, fail. What's the difference? What's the difference? What's the difference? What's the difference? Place. What's the backtrace? Backtrace. Backtrace. Right, we need it on here as well. PCB side. And we're going to need it on each of these. Kaplop, kaplop. Fine. Okay, that worked. That's good. Now we've probably got the same problem with the KiCad stuff. So we've got side with a capital T. Let's check the KiCad one had a capital T in it. No. So then at some point there's going to be a PCB side which is going to have a capital T, because that's how we serialize that one. Right. Hey, it's fixed again. Okay, good. So now we've got a PCB side. That was good. Let's go all tests. So we put cloud. What? Oh, I don't. That was an error. This value enum is the clap one. I thought that was the Surde one. I was getting those two confused. Yeah, we don't need that. Now, this is supposed to be the Surde one. Again, I was getting confused between the clap and the Surde things for this. And this is going to be lowercase. Right. Oh dear. Many errors. But it's all fine. So I suppose. Oh, what's happened there? Oh, there's some formatting error going on there. Okay, fine. Oh no. Uh-oh. Everything's fine. Yeah. That should fix some of them. Not all of them, though. It's kind of weird just blindly adding PCB side everywhere, isn't it? I mean, clearly it's not important for these tests yet. Perhaps we could use the ... default or whatever like this. But I'm not entirely sure there should be a default for a PCB side. It feels like it's something you should specify. Much tests to change. We're going to have to go through all this when we start adding the X and the Y and the rotation on as well. You're going to be touching the exact same files. Oops, we need this. But you know, EDA placement's fairly cool, so you would kind of expect that a bit. You know, at that point we might decide, you know, there should be a default coordinate that you don't care about, like 0, 0, for instance, you know. Come on, there can't be many more left. We've got 2 warnings. Alright. Everything passes. Fantastic. Right. Those are okay, they're old ones. So, let's just run all the tests on the command line. And refresh our memory. 4 failing tests. Fine. So this is in the planner. Right. Let's have a look at one of these. It's probably that there's where's my click to see difference button? There it is. Oh. I wasn't expecting that. Right. I have an idea of what the reason is for this. I think when there's some kind of parsing error for the CSV records, it basically just ignores it without spitting out anything yet. This is something that needs to be improved. Where is that bit of code? Let's have a look. So it loads up some parts somewhere. Load all placements. I think it's somewhere in here. Load placements. I think it's this. right? Yeah, and then if there's an error, you get so this is where we hide it, somewhere around here. So let's say to do report errors. Now, why is there an error in the first place? And also, there's a trace thing here, so we could perhaps look at the trace log to see what's here. So this is the error look. So that's from this trace. Unknown variant top, expected top or bottom. Happy days. That looks good. So we're loading placement somewhere. But I don't think this matches what the variant builder just wrote. Let's go back to the variant builder for a moment and look at where it writes the CSV file. So we said the expected CSV content has a capital T. Right. So this is correct. So where we specify the stuff that gets used when we're deserializing things, that's where the problem is. So we've got this placement record, and we've got this placement record PCB side, and we've got lowercase, and this should be Pascal case. There we go. Now that should fix it. Yes, it did. Happy days. Okay, good. Good. Right, so this one fails. I don't know why. Let's have a look. Okay, so we've got PCB side, and we probably just forgot to put it in the test. We're missing PCB side from these. Yes, that's good. That's good. So after these, there should be PCB side. I think. Oh, not there. Not there. Here. Oh dear. Oh no. What happened there? Too many commas. Just paste and fix the indentation. That's it. Paste. Fix. Paste. Fix. Everything works again, but we're not using the PCB side yet, so no. Really, we sort of want one component that's like on the bottom or something stupid like this, right? So maybe that J1 that we've got up the top, when we do this, we'll move it to the bottom. But that doesn't really, no, that doesn't really help. What we sort of want is a test case that says, because we're saying match all the resistors is what we said. I think we'll test that at a unit test level at a later date. I think that's going to be better for now. Otherwise, we're going to be fapping about with these JSON files forever. Yeah, but we don't have a. I don't like it though, because I need to write some code, and I don't have a test for it. But I do have my to do. You see, I've got this. Where is it? refresh parts, kind of placement, it's not that bit. This bit. Ensure the placement side matches the PCB phases unit side. Basically, we need another thing here, and yeah. So apparently we do need the state in order to check the size. State dot placement dot PCB side is, and then we need the side for the phase. So we've got to look up the phase. Let's just say phase dot PCB side like this. Right? So we've got this phase name. We're not even using this phase name, and this is let's rename this to phase name, and then let's phase is going to be project dot phases dot what? What is phases? Is it a B tree map? It is a B tree map. So we can go dot entry get, yeah, dot get, and then phase name reference. Is that right? No. Expected reference. So it's possible that our well, one of them's an argument, and then we've got yeah, okay. Let's just say phase reference. Maybe we can do it like this. Do you just go OK on these things, converting between options and results and things? How'd you do it? We've got an optional thing. Private field. I'm not sure this phase name should be this, because where we've got this reference here, I might have to revisit that. And the phase has got a PCB side, yeah. Can we say .ok? Oh, I'm being a muppet. Okay, so now we've just got to deal with this, and also the fact that this is not entirely right. How do you? How do you go from an option to a result? I'm looking for a method which does it look OK or else. OK or. And then what, do you specify the error? Unknown phase? But it's giving me a reference, but why? Oh, we need to get yeah, okay, or we've got some kind of error. Yeah, we need some error handling. Like, yeah, I don't really want to deal with this yet, but there we go. Let's just do it the hard way for now, and then we'll deal with this stuff later. I don't like this, but it'll do. If it's okay, right, if it's not okay, we go bail. And yeah. And that'll shut the compiler up for a bit. And then we'll do the same thing here. We're going to go match this. And if it is something, then we'll return it. Otherwise, we go bail. And at some point, we'll improve the error handling into this. And it's going to be unknown phase. We'll do the same thing here. Right. So that's how that could fail. But now we've got a phase that we can use. But it's trying to move it out of that. So obstruct its phase, but then we can't. Do all these need to be public now then? They do. It's the first time we're using them. Right. Okay. This is good, we did it. Let's make sure that we definitely did it. Right, so if we change the side, we need some more unit tests for all this stuff a bit later. But let's make sure it fails when we change the side of one of the resistors to bottom. Right? Because we're supposed to be matching all the resistors, and now it should only match R1 because the other resistor is on the bottom. So this is the one we're interested in. And we're looking for one missing phase on here. Look, you see? Phase, no phase. It works. We need more tests for it, but we don't have them yet. Okay. To-do done. To-done. Ta-da! To-done. Right. Done. Yay. Okay, this is great. Let's run all the tests on the command line. Kabam. Oh. What's this? Phase. We don't need phase. Planner. Line 13. Line 13. Phase? Yeah, we've got this reference and phase name. I don't know. We need to look at that. Yeah, okay. Alright. Run everything again. Okay, cool. Let's just do a commit now. I'm not going to amend it, I'm just going to add all that stuff to it. We'll come back and poke the commit in a bit. I want to have a quick look at this. Actually, no. Now's a good point. Now's a good place to do it. Okay, so let's review. So we go git reset head. Right, and then all of the things that we want to commit are now unstaged. So now we can do a proper commit message. So what did we do? Well, one of the things we did was added PCB side support, right? Because that's all this stuff in the variant builder, right? Everything's fine. This is all PCB side stuff. That's all good. And then we've got PCB side, and all this kind of stuff, right? Oh, hold on a second. Yeah. Was all that stuff there just PCB side? It was, wasn't it? Okay. Wow, it's changed a lot of stuff, didn't it? So all of this is PCB side. Yeah. Yes. Okay, so this is just that, in fact. No. All of these things. That's all PCB side support. Right, but we've got this other commit, which is this one, which has still got work in progress on it. So this is all the other stuff that I want to review. So rather than futzing around with Git too much, we'll just edit the commit message and then review it. But in order to type the commit message, I need to review it. So we're going to look at the tests. What did we do? So this was basically assigning placements to phases. Yes, that's what we did. Assign placements to phases. There you go. Right. Now we can review it and just make sure there's nothing funky in there, and if there is, we'll go back and amend it. And then squash it. Yeah, create a new commit and then squash it. Hopefully there's nothing bad in this. So we've got the path stuff, we've got... Yeah. So we went through this at the beginning of this stream. Yeah. And we updated these. Yeah, that was all good. Yeah. Yeah, delete some stuff there. Added in the object path. Quick look at that. Yeah. Oh. No, that was okay. And then we've got the placement state. We added the placement state. That was quite a lot of work. Much code. Yeah. Much code. The new command, the refactoring, the new command details, yeah. And then all the stuff to do with finding the changes. Ah, there's a to-do, we've got to do this in planner.rs, yeah. I have to come back to that in a moment. Yeah, okay, so that's all good. Close all tabs. Planner.rs, this one. So there's a to-do in here, which is this. Let's have a look at this. See if we can work this out. We don't have a test case for this. I kind of want a test case for this. I mean, It's quite a faff, this bit is. What we could do. As a should we do this right, or should we do this sort of temporary fudge in order to get this done? Because we need to refactor all these methods that are sort of sitting around this bin file into something, and I don't really want to do that bit of refactoring just yet. Let's fiddle around with a test for a little bit. What we can do in the first test, we can write the CSV file out with an additional placement in it, and then the second test, that should change the state of this thing to then be unknown. That's what we're looking for. So let's try and do that. So this is where we create the file, right? So let's do all three variants in here for now. We're going to delete R1. No. We're going to add R3. Yeah. No. Let's say C1. Right. And then in the next one, and then, well, so when we do that, we're going to expect parts to contain cap manufacturer 1. Cap 1. We might have to change the order of these. In fact, we will do. Oh no. Because these are going to be alphabetically ordered. And we have to fill them out with commas, right? And let's just say, let's just say it's on the bottom, just so that we're exercising a bit more of this code. Oh, wrong one. Cap. Right. Right, and then the next one, what we're going to do is write the original file back again. And therefore, we should have the part deleted from the list of parts, and this placement. Oops. This placement should have a status of unknown. That's what we want. Why is it moaning about that? Yeah, this is a bug. This is a bug in the IDE. See what it did? Look. Why did it do that? Okay, so we created a job and it's got all the things in it that we wanted. So this one works, and we've got our capacitor first in the list of parts, right? Then when we assign this, right, this is the one where we've said we've changed the list of parts now, right? What happened? Okay, the order of this is slightly wrong. The capacitor was first, so let's fix up the order. We should also have the resistor. R1, so we should have R2 in here as well now. Let me steal that from the other one. R1, R2. There it is. No, this one should have that. Oh, am I getting myself confused? Probably. Right, good. This one, right. It's just got the wrong state in it and everything that's right. And this is what, now we've got a test that we can work with on the production code. Right. So we need to do something here. So we need to look through this map and there's a list of placements for each of the design variants. And then if the new map if the project's list of placements contains something, it needs to contain all of these things. Yes, okay. So we probably need to iterate over something in the project. So we've got the placements. And we need to check each one of those to see if it's in that map. And if it's no longer in the map, then it's unknown. Then we need to change its state to unknown. So we've got path and state. Right. So our placement state, path. Is it just the ref des that we're interested in? So it's basically if we don't find a key for it in the map, okay. But the map, the key for that, we've got a vector place, fine. Sure. So we're going to need this. Right. So now we've got the placements, and then we've got a placement over here as well. So we can say let's go bool, and there's probably a better way of doing this. Let found bool equals false. Right, we can poke the implementation of this, but let's just do it like this to start with. So we go right. Well, the placements object path has got a PCB unit assignment, but the PCB unit assignment needs to have a design. Has got a design variant assigned to it. Oh, it's complicated. Yes. Yeah. Yeah, we need to build the object path. We need... Oh, dearie me, this is... Oh, nightmare. Okay. Unit assignments. Yeah. So do we iterate over the unit assignments first and then go over the design variant? Yes, I think we do. I don't think we need to iterate over it like this. So if it's something like let's go. I'm thinking about looking at the strings and going, if one thing starts with the other thing at the moment, just as a temporary sort of thing to do it with. So the object path has got like PCB. Oh no, it's not. Oh dear. Ugh. Ugh. Brain hurts a lot. Unit assignments is a B-tree map of unit path to design variants. Right. And the object path, yes. Okay, no, I was right. And then go if the pathster starts with the unit pathster, and then let's go trace. Let's look at these because I want to see what they look like when they're converted to strings. How do we do this? Do we have a reference to it? Yeah. Right, so we've got path stirrer is this, and the unit path stirrer is this. Do we want to build the other thing? Hold on. Oh my gosh. So if it does match, then we need to look in the map, which is the updated map, right? Oh, this is complicated. And this is a map of design variants, which we've got here. Yeah. And we don't do anything, it's fine. So we're iterating over a placement state. Yes. So if let's say let existing placement is placements dot iter dot find okay. And we need to say if this placement dot refdes is the same refdes as the state's placements refdes, then we found it. But if it's not, then we need to change the state status is unknown. Something like that. And there's a clippy warning. Yeah, we can poke that. Shush Clippy. Something like that. Oh, exactly like that, in fact. Dun, da, 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 da. That was good. So we're going over some stuff, and we've got this path, and we've got a unit for it, and they're the same. So you go, great, we match the unit. And then we look for the placement in it, C1, but it's no longer in the map anymore. So we go, it's unknown. And then we go along and we find J1, and we find it, which is good. And then we go along, we find R1, and we find it, which is good. And we've also found the new part, which is resistor 2. We've got this new placement, here it is, resistor 2. It works perfectly. Fantastic. That's not the easiest bit of code to write. Yeah. Well, yeah. Oh. Oh no, we don't need this. We don't need this found thing. We just updated the state directly. I suppose what we could do here is just a little improvement. We can go let matched unit or is matched unit, and then we just do this bit, right? And then instead of doing this here, just to keep it a bit less verbose, we do that, right? Just a little bit. There, like that. Yeah, it passes. Right, now let's update the other two tests to fix up the differences in it. So we've got this placement state unknown, which we're going to have to unfortunately keep with us for a bit. It's fine. So it just goes on the top of the list of placements. Fine. It's just an unknown placement now. There we go. And that's going to be the same over here. go. And everything should pass now, right? Pass or fail? I think pass. Yes. That crowd goes wild. Cheers. Yay. Right. Okay, sorry. Responding to random messages that are coming in. Let's have a look. Face cam to top left. Yeah, the problem with that, Darkman, is that it gets in the way of like everything else. The bottom right for the face thing is yeah. Let me have a look. Yeah, you don't see the whole message. I see what you're saying, but if I move it anywhere else, it just obscures like way too much stuff. I could bring in this a little bit to the left, but then I don't see the names of the tests properly. You know, I'm recording in 1080p at the moment. We could bump that up, and then my IDE could be a bit bigger. And if we went to like 1440 or something like that, would be a way of doing it. Yeah, okay, so everything works there. Let's run the variant builder. Everything runs there. Let's run everything else. Everything runs there. I think this bit's sort of done enough at the moment. Yeah. This is good. This is great. Why did this come? Why did that? I didn't add that. No. That's my IDE doing weird things again, accidentally, isn't it? Okay. So I suppose now we need to run everything again, don't we? Yes. Okay. So what do we do here? So yeah, we added a thing in that gets removed. Added support for. I guess it's removing a placement between project refreshes. Yeah. So we added C1 and then we take it away and we put something else there instead. And that exercises all of the code to do with the placements and the parts and all the rest of it. Right. We could probably improve this a little bit by checking for the trace message. Yes, let's do that in a moment. Let's do that in a moment. Let's do that. Right. So, in our tests, for the planner. Right, so we've got this new placement thing, right? Let's add that here. Because this is actually important for this bit now. Yeah, we can definitely improve this. Okay. So unit assignment added comes first, and then the placements come second. So let's say we want this. Yeah. Now we've got to escape things. Okay. And then we got C1, J1. Cap Merfer 1, Con Merfer 1. Con 1, Cap 1. And this is going to be bottom. And this is good, right. We also want the details about these new parts as well. So let's add these into. And we need to put some quotes in. And we're going to use capital letters because humans. Cap, con. There we go. So we want, though all these things should happen in this first test, right? But they won't happen because we've got a capital N, and we're going to fix this as well while we're here. New placement. New placement. There we go. And then we're going to use a capital M here. Okay, good. Should pass again now. Right, perfect. Now this next test, when we remove some stuff, it's going to say that it removed some stuff. So we've got a new part and a removed part. So this is what we need. This is going to be much more robust. Like this. So we've got added process. So it has to do all the stuff to do with parts first. New part. Hi, Commander Guy. Yeah, things are going fantastic. We made really good progress. So you can see by my passing tests, yeah, and we're pretty close to being able to do this. That's where we're at. We're just making the tests a bit more robust. There we go. So we do that. So we've got the removing the part and the new part, and then we've got the changing the placement state from known to unknown, and then there's a new placement as well. So we've got the parts up here, and then we've got the placement changes over here. So we've got a new placement. And I think we're missing an error message. We're missing like some trace message because we haven't got a thing where we say the state changed. So we need that. I'm pressing the wrong key on my keyboard. There we go. Some of these, some of those. Some quotes. Yeah, like this, right? But we're missing something. So where we process the changed placements above here, so we find the placement change. Oh, you see, look, I've done this wrong, haven't I? I was supposed to return a add it to the list of changes, not change the state directly. Right, so we've got to move this code. What we're supposed to be doing is something like this. Right. Where it's unused now. And wait a second. How can we have a placement here if oh yeah, I suppose I mean, if you don't know, if you haven't got it, I mean, like, we know about it here. It's probably going to be state dot placement dot line. And then this bit is not supposed to be here. We're missing a bracket. Yeah, we were missing a bracket. We're supposed to deal with that here. Marking placement as unused. I've already written the code for it, but I just didn't return the right thing. Let's see if it still works and look for this in the log. Hopefully it still works. Yes. Dodged a bullet there. Okay, so we were updating this test to say that the log messages should contain some stuff, and one of the things that it's supposed to do is marking a placement as unused. This one, we want this. In here with some commas and some escaped quotes. Thus. Pass. It's going to pass. Yes. Okay. Phew. I was mixing my finding changes to dealing with the changes code together. It was, yeah. Right, it's fixed now. Everything's fine. Everything's totally fine. Time for a commit. What do? I guess it's like improved robustness of this test, right? Improved robustness of, I don't know, placement and part refreshes, because all this is done in part of the project refresh thing method. So let's just have a look at that. So we've added a bunch of messages that we're supposed to look for, and we've got a bunch more things that happen, which is good. And in order to do that, we updated some messages to use capital letters and fixed where the handling of this code was. And that was it, yeah. Easy. Dunsky-doo. Let's run all our tests. Hey, it's all good. It's all good. Right, so where are we now then? Where are we? I think it's done. It's done, skidoo. Right. I think this is a pretty good place to leave this for now. I might do a little bit of refactoring, or I might think about the next thing that we're going to do. Yeah, assign loadout to phase. Let's have a quick look at it, just so that I can get my mind thinking about it. Assign loadouts to phases. Now, I did some of this already, but I did it wrong. So we have to do it again, but properly this time. Let's have a quick look at the last test where we've assigned placements to a phase. So we've got our phases, and it's got a name, which is also here. And it's got a process, and it's got a loadout. What do we say we want to do? Assign loadout to each phase. I've already done it. Because it's done in create phase. Create phase has an argument, which is the loadout. Okay, fine. That was easy. Right. I thought I'd done that one. Currently we can't change the loadout for the phase. But you know, we're doing a vertical slice. We can add the bells and whistles later. You know, when we get to here and want to go back here again, that's when we need to do it. But we have technically assigned a loadout to a phase. Yeah. So now what we've got to do is assign parts to a loadout. Right. What parts? Where did the list of parts come from for the loadout? I mean, we say that this phase is using this loadout, and the loadout might be completely empty, or it might have some other things in it that aren't needed, but that is okay. So we need to say some of these parts that are going to be placed in this phase need to be in this loadout. And you probably would be, if you had a user interface, you'd probably be presented with a list of parts for the phase, and then you've got your loadout on the right, and you would select them all and then say, yes, all of those please, and then it would be done. Or you might sort of multi-select them by name, part number, whatever, and then say, right, now these ones are in the loadout. Right? So, yeah. So the problem we had before, when I first did this, is that I thought a part could only be in one loadout. That's not true. The same part can be used for multiple phases. Why you might want to use it in multiple phases, because one of the phases could be for the top of the circuit board, and one of the phases could be for the bottom of the circuit board. and you might have the same part on both the top and the bottom. For instance, 100 microfarad or 100 nanofarad capacitor, for instance, right? Decoupling cap. You would use it everywhere, top and bottom. So essentially, you need to build a short list of parts for the phase that you can assign to a loadout. But now that we've got our placements assigned to a phase, we can look at the placements for the phase and then build a short list of unique parts for that phase, for which we can say these can be in the loadout. That's what we're going to do. But we're not going to do it now because I'm hungry and I need food. Right. So, yes. Hope you enjoyed today's stream. It's been very productive today. It's very good. I'm very happy with the progress. Alright, so don't forget to click the like button, subscribe if you want to see the next stream and so on, which should probably be tomorrow. Yeah, it should be tomorrow. I think we're on Thursday today, aren't we? Yeah. Okay, guys and girls, and whatever else you are. Just remember, it's only software. How hard can it be? We'll find out on the next one. See you later.